In yesterday's video, we have seen that the cross VLAN communication was not happening. Our ping was failed. Today, we are going to fix that. The topic we are going to cover is called the router on a stick, where we are going to introduce a router and we are going to connect it via switch. The interface on a switch will be configured as a trunk port, and the router interface will be divided into the sub interfaces. This kind of arrangement is called router on a stick. If we successfully achieve it, our devices will start communicating with other devices in the different VLANs. So, two questions come into your mind. First of all, what is happened when we introduce a router into our network and our devices in the different VLAN able to start communicate with each other? So basically, communication within a LAN is a scope of a switch. But if you want to communicate multiple LANs together, it is a layer 3 communication, which is the responsibility of layer 3 device. Either you can use a router or a layer 3 switch. And second question should be if you want inter-VLAN communication. So why we divide them at the beginning? Because we want to limit broadcast traffic. Routers do not forward the broadcast. So even if broadcast happen, it will limit to the router only. Router will not forward it to the other VLAN. We have achieved security, we have achieved optimization, and now we will be able to communicate within the VLANs. We have enabled the inter-VLAN communication. So let's see how can we do it in the lab environment. I'm starting everything from the scratch. I have just introduced a router in yesterday's topology and connected to the switch. First of all, I will make this interface F01 on a switch as a trunk port because this port supposed to carry multiple VLAN traffic. Go to the switch, enable config T interface fast Ethernet 0/1 switch port mod trunk and write show interface trunk. So let's verify. Since this link is down, as soon as the link will be up, our VLAN also start appearing over here. By default, we know that the ports are disabled on our router. So let's configure and enable it. No enable config T interface G00 G0/0. No down. So since the link is up, and if we try to see the same command, so we can see our fast Ethernet 0/1 under the trunking. So we have configured one side of communication. Now we are going to make sub interfaces. What does that mean? We are going to divide this physical interface into the two logical interfaces. This is the similar concept where we have configured multiple VLANs on a switch, and switch is divided into different logical switches. We are going to divide this physical link into two logical links. How can we do that? So let's see. So in the global configuration mode, you use interface G0/0 dot. When you use the dot, and now you have to enter a number. To make it easy, I always use the VLAN number here, but you can give any number over here. So now .10 means it has created a sub interface. Encapsulation .1q. Now I have to tell that this sub interface belongs to which VLAN. So as I told you earlier, I use the same number of the VLAN here. So I'm going to assign VLAN number 10 over here. Then I have to give an IP address. IP address which is going to be the default gateway for every device on that VLAN. So 192.168.1.255, 255.255.255.0. We cannot assign broadcast address, so 254 is going to be the last usable address. If you do not understand this concept, the last usable address, I have posted videos in the last week. You can see the video of subnetting and VLSM. Exit. Now I have to create another sub interface for VLAN number 20. So dot 20 encapsulation dot 1q. This subinterface will be is associated with VLAN number 20. Now IP address 192.168.2.254.255.255.255.0. And right, let's confirm show IP interface brief. And now you can see that we have successfully created two sub interfaces. We have assigned the IP addresses and both interfaces are in the up. So now if we configure the default gateway on the devices, they will start communicating out of the 92.168.2.254. I'm going to copy it and I'm going to paste it on every device within the same VLAN. Right. For these devices, we have configured 1.254. We have introduced a router in our circuit. We have configured this port connected with the switch as a trunk port. We have created sub-interfaces to the port which was connected with the router. The IP addresses configured on the sub-interfaces are assigned as a default gateway for the end devices. So now these devices should be able to communicate with each other. So now let's test this. First of all, let's ping within the same subnet 2.1. So ping is successful. Now try to ping out of network 192.168.1.1. Our PC4 want to communicate with PC 1-1. The first attempt is failed because it's trying to find out the way. But after that, you can see that the ping is successful. Now the same device is able to communicate within the same LAN and also as well as out of the LAN. So this is how router on a stick configuration works. If you have any confusion or if you have any question, please post in the comments. If you find this video useful, subscribe to the channel. I'll upload the more videos as well. If you are looking for a free session with me, I'm going to share the link in the description. Thank you so much. Bye-bye.